second derivative. First, we need to find the first derivative. Okay, did everyone get that? Get y prime by itself. Okay. I went pretty fast on that negative x over y, so let me stall there. Any questions about that? Subtract the 2x over, and then divide by 2y. The 2's cancel. Let me show that extra step. So I get 2y times y prime equals negative 2x, getting all the dy's on one side and all the non-dy's on the other, and divide by 2y. The 2's cancel and I get negative x over y. So now I want to find the second derivative. You find the derivative of the derivative, right? Yeah. What rule will I need to find the derivative of this? Quotient rule. So I have low d high minus high d low. What is the derivative of y?
Derivative of y.
That's right. Sounds silly, but it's right. Over y squared. Now, most of the time when it asks for this, it asks you to write it in terms of x and y. I have something that's not just an x or a y, and that's the y prime. I would like to get rid of that. Well, what is that? It's negative x over y. So the second derivative in terms of x and y is negative y plus x. Oh, okay, with how I got the plus x. Negative, negative. Where I see the y prime, I'm going to replace it with negative x over y. That's how you do a second derivative. Everything from here on out is simplification. However, I would watch closely. It will help you with several homework problems, including a bonus problem. Two options from this point to simplify. Easy option and a hard option. Most of you will choose the hard option. It's okay. Easiest option is to multiply the top and bottom by y. Why would I choose that?
Because
Gets rid of that y there. The other option is to get a common denominator on top, combine the top two fractions, then flip and multiply. You'll end up in the same place a lot slower than this. So I get negative y squared minus x squared over y cubed. Everyone agree with that?
what do you have to simplify though?
I would watch. It will help you with your homework. Do you have to be able to simplify in calculus?
No.
Oh.
Yes.
Why?
Oh.
Multiple choice problems, right? In fact, number like 3 on your homework, this thought process that I'm about to walk you through will help you with that one. If any of you had the one with the e to the y and the cosine, I imagine a lot of you got stuck on that one. It was tough. I have two, one over there and one behind me. The e to the y equals cosine of x or something like that, or sine of x. Implicit.
Are you talking about number 6?
6.
Oh, yeah, right. Never mind.
Anyway, everyone watch. Everyone watch. Now, there is no reason that if I worked matching a multiple choice answer that I would go past this step, because that's pretty simplified. However, AP, they're tricky.
Yeah, that's good.
You see how I could factor out a -1?
Yeah.
I don't know why you want.
What was the original equation?
X squared plus y squared.
Oh, it's 10.
What was the original equation?
X squared plus y squared.
Oh my god,
Oh.
that hurts me.
AP will do that to you sometimes.
Okay, that's just evil.
Slightly evil.
Wait.
But we can see that the thing is, we will know their tricks. They can't trick us. We're going to know they're coming.
I just don't get what it's saying.
That's the original square answer.
Oh, those goobers.
Yeah, they're evil. For open response,
Slightly
could we have left it at the step?
Oh yeah, for open, everyone listen. For open response, you could have stopped right here.
We could just post it.
It depends. If it's said in terms of x and y, you will need to go on to this step to get rid of the y prime. If it doesn't say that, then yeah, you could have even stopped at the previous one. But a lot of times on this question, they will say in terms of x and y. But for multiple choice, we might have to do something crazy like this. Those of you who got stumped on number 6, look for something weird like that. Okay. All right, let's look at one more, and we'll be done for implicit,
Oh, please.
not for the we got some tangent normal stuff to pick up. Although most of that y'all probably know, but just a couple little things. And all right, one more. This one has a sign in it. Just a nasty implicit. Find the derivative. Cosine of what? Leave the inside alone. Does everyone agree with that? Times
2x plus y prime.
Very good. So that's the left. Any questions about the left-hand side of that? Whoops. Didn't mean to do that.
See, they're really easy in class, but then when I get off the homework, I have no idea what I'm doing. That's how I feel.
Yeah.
I just don't like how they word their sheets are weird.
Yeah.
Okay. Yeah.
Okay, let's look at the next one. Left, d right, plus
1.
right, d left.
Oh, okay.
Turns out this problem's pretty tricky on getting the y primes all on one side of the equation. Because they are grouped in 2, I'm going to have to do some distribution first. Okay, what all did I do there?
Switch the 2x to
Distribute the 2x, or the cosine of x squared plus y to the 2x and to the y prime. Because I'm going to have to get the y primes by themselves. If I don't distribute that, how am I going to break it up? Now I have 2 terms with y primes in them.
Where did the 2x come?
Nope, 3 terms. 3 terms with y primes.
Yeah, where did the 2x
The 2x, right here. Okay, this thing here. Distributed.
Oh, the whole. Okay.
Well, you can't distribute just x squared plus y, can you?
No.
Because it's trapped inside the cosine. I'm going to get all the non-y primes on one side and all the y primes on one side. those were all the non-y primes. Does everyone agree? This one has no y prime with it, and this one has no y prime with it. I'm going to put all the y primes on the other side. I'm going to go ahead and factor out the y prime. If you don't want to do that, you wouldn't have to. So I get 6xy plus 2y minus cosine of x squared plus y.
How did you distribute the right side? One second side.
Okay, so the 3, this
Yeah.
piece was just sitting there. Then this one, the 2y prime times the 3x,
Oh.
and the 2y prime times the 1. So that one was a yucky one. Just wanted to see you to see a really yucky one. So we finally finished implicit after all those short days.
Is that
Which one? The cosine y is at negative? Because it was on the left-hand side of the equation, and I moved it to the right.
that's just the derivative of runs.
Yeah, that's just the first derivative. This one didn't ask me to find the second derivative. Thank goodness, because that sounds horrible.
You're not wrong.
Where is y?
Why is Did you factor out the y?
Which one, Devin? It had a y prime sitting next to it.
Oh, yeah. That's what I said. Thank you.
Okay, so that concludes implicit. Now we're going to move to some tangent and normal stuff. We're going to go pretty fast through this bell ringer, but it is worthwhile to look at because it's something I could see AP doing. They ask me to find h prime of 1, and they tell me h of x is f of g of x. How would you find h prime, first of all?
Outside.
Good, it's a chain rule. Does everyone agree? H prime of x would be, in fact, isn't this something you have to memorize for your mastery exam?
Yes.
You need it forever.
You've already Oh, yeah, you did.
Miller, are you taking notes? G of 1. How would you do that?
Where did N come from?
Where did what come from?
Okay, I got it.
How would you find G of 1?
Look on the graph.
Look on the graph. G of 1 is 4. How would you find G prime of 1?
Look on the prime graph.
I don't have one.
Prime of 4 is 0.
What is a derivative? By definition, what is a derivative? Slope of a curve at a point. What kind of curve is this?
It's no
Straight
straight
one.
A straight line. Do I know how to find the slope of a line?
Yeah.
Yeah.
Rise over run.
Rise over run. What's it doing? It looks like we're going rise 1, run 2 to the left.
So 2.
So negative 1/2.
1/2.
Negative 1/2, right? Do what? I don't need that anymore. Because I just found the derivative of g at 1. Oh yes, sorry, there is an f. You're right. That's what I thought you were talking about on the negative 1/2. Sorry. Yes, you're right. F prime of 4. Can I find that? Negative 1? Why is it negative 1? Negative 1 slope. So negative 1 times negative 1/2 is positive 1/2. I'm not going to do the next one, the s prime of 5. You would do it the same way, except when I do s prime of 5, one of the questions, which I don't even remember which one, ends up being at one of these sharp corners. What do you know about the derivative at a sharp corner? There is not one, so this whole thing actually does not exist, I believe, if I am remembering correctly from last year. All right, derivative of a logarithm at first glance. However, what is always my recommendation for derivatives?
Rules.
Before that, what do you do before you do calculus, if you can?
Algebra.
Algebra. What's the natural log of v?
1.
Okay, so what's the natural log of v to the 2x?
2x.
What's the derivative of 2x?
Whoa.
Alright, so what if I don't remember the algebra? Is there another one?
There is,
Okay, so
but it would be natural log and e are inverses, so they cancel.
then what would you do?
Now you would do a chain roll with an e to the 2x as your u on natural log. So it would be e to the 2x on the bottom, and then the derivative of e to the 2x on top, right? And the derivative of e to the 2x is e to the 2x times 2. And then the e to the 2x on top and bottom would cancel, and you just do it for 2. So you would end up in the same place. It would take you longer.
I really
All right, last question. The function is differentiable on the interval 1 to 10. F of 2 is negative 5. F of 5 is 5. One of the biggest mistakes calculus students make is not drawing pictures. It can really help. Yes, I know y'all are too smart for pictures, but just draw them anyway. It won't kill you. Okay, we have a differentiable function. What does it mean if a function's differentiable?
Doesn't ever break.
Doesn't ever break, and it's smooth, right? So it is continuous, and it's a smooth curve. There's no sharp corners or anything like that. So,
You didn't draw it, but
oh, sorry, that I drew f of 5. You're right. Let's fix that. 1, 2, 3, 4, 5, 6, 7, 8, 9. There we go. 7.
now you have to
now you
draw.
Oh, never mind. Okay, hold on. You're right. They gave me 3 points, didn't they? Helps if you draw it right. It's good. Oh. You'll be. Okay, and then 9, 5, 6, 7, 8, 9 is negative 5. Hey, y'all will be. I worked hard on it. Huh? So, f of 2 is negative 5, f of 5 is 5, and f of 9 is negative 5. Which of the following must be true? Do I have at least 2 zeros?
Yes.
How do you know?
Because it's differential.
I've got to cross the x-axis here, and I've got to cross the x-axis here, right? I don't have to go that smoothly, but I have to cross the x-axis twice. So this is true. The graph has at least one horizontal tangent. Would you agree that I have to turn around somewhere?
Yes.
It doesn't have to be here, but I have to turn around somewhere. Now, it could be a sharp corner, but it can't because it says differentiable. So I would say yes, I have to have at least one horizontal tangent because I've got to turn around. For somewhere between 2 and 5, is f of c equal to 3? Yes. Everyone agree? So 1, 2, and 3 are true. Was the picture very, very helpful? Yes. Now, we actually used 3 theorems there. One theorem you don't even know yet that we'll talk about later. This is intermediate value theorem. Actually, 2 theorems. This one's intermediate value theorem. This one's intermediate value theorem, right? And then this third one you don't know yet. It's actually called the mean value theorem that we'll talk about later. Okay, we did that problem. Okay, we're going to go pretty fast through this lesson because we've already talked about it quite a bit. But we're going to talk about tangent and normal lines. You don't have to write this down. You can if you want to. It depends on what you know and don't know. But I do want to take this time to compare and contrast algebra and calculus. In algebra, we found the slope between 2 points, which was the average slope. That's always what we were finding when we found slope. Average rate of change, average velocity. We learned that we might not have known what it was called, but we were finding the slope of the secant line. So this is all algebra stuff. If it asks you to find the slope of the secant line, you are doing algebra 1 stuff. y2 minus y1 over x2 minus x1. Calculus took us to where we could find the instantaneous slope, or the slope at a point, or the instantaneous rate of change, or the instantaneous velocity, or the slope of the tangent line. And we learned that that was a derivative, which involves a limit, and that's why it's calculus and not algebra. We're going to look at finding tangent and normal lines today, which we've actually already done, but we're going to do the formal lesson today. And then what we can do with a tangent line. The first thing we're going to look at is what's called a tangent line approximation. This turns out to be really important in the real world, and in Cal 2 you'll get to some things where you really see the importance of this. But would you agree that really, really close to this point, the tangent line is close to the curve? Are there some curves that are really hard to plug numbers into by hand? And if you don't think so, try sine of x at any point other than a unit circle point. Is it difficult to calculate those values? Yes. So we could use a tangent line to approximate the value at a point that's not a unit circle point, that's close to a unit circle point. Turns out in Cal 2 you will really explore this a lot. In Cal 1, in this part of calculus, we'll just do tangent lines. If you are close to the point at A, then the function and the tangent line are almost identical. The closer you are to the point, the closer the tangent line is to the curve. You can approximate f of x with the tangent line. So, it says use the tangent line to approximate f of 2.1. If I am asked to use a tangent line, what must I first find? A tangent line. I can't use it if I don't have it, right? What are the 3 things I need to find a tangent line? And what is my x? 2. And how do you find the y? Plug it into f of x. So y is f of 2, which is, and did you say it was 2? 8? I don't think it's 2. 8/3 minus 4 plus 1. This is 12/3, right? Everyone agree? Yeah. So 8/3 minus 12/3 is negative 4/3, plus 1 is negative 1/3. How do you find m? Slope of a tangent line.
Derivative.
Ah, the derivative. X squared minus 2. So what is f prime of 2?
4 minus 2.
Good. If your slope has an x in it, you did something wrong. Don't put this down as a slope. That's the slope at any x, but I want to know the slope at 2. So don't put x's in your tangent lines, except where an x goes in a tangent line.
5 plus 1/3
Good. Y plus 1/3.
equals 2 minus 2.
Now, the question asks me to use the tangent line to approximate f of 1 or of 2.1.
So plug in 2.1.
Plug in 2.1 in for x. And good, if you wanted to solve for y first, you can. Or you could do it later. It's up to you. Just subtract the 1/3 over. It doesn't make any difference. Plug in 2.1 for x. What is 2.1 minus 2? Good. You get 0.2 or 2/10, which you reduce to 1/5. 1/5 minus 3. Or you could do 0.2 minus 3, and I'm fine with that. You get 2.8. Oh, 1/3. Never mind, I lied. I'm sorry. I'm glad y'all are paying attention. Okay. So 2/5 minus 1/3. No, 2/10, which is 1/5, minus 1/3. So 1/5 minus 1/3, which is 3/15. Yes. And I'm going to say that that is approximately f of 1.2. Now, a lot of you don't want to write approximately because you put a fraction down. But why is it approximately? It is 2.1, you're right. I'm glad y'all are on top of things today. Why is it approximately?
Not exact.
It's a tangent line. It's not even the real function, right? It's just a tangent line approximation. So the function is approximately negative 2/15 at 2.1. Okay, let's look at the next one. Whoops. Find all points on the curve where the tangent line is horizontal. That says x squared minus 2x plus 6. How am I going to find that? How am I going to find that? How am I going to find it?
Find out where it shifts.
Yeah.
Oh, find the x's values.
X values of what?
0.
Denominator.
Where what's 0?
Where y is, or y slope is.
Where the slope is 0, right? Horizontal tangent lines have a slope of 0. What is the slope? If I want a horizontal tangent line, I need to know when the derivative equals 0.
So at negative 1.
Almost.
Positive.
So, where is the tangent line horizontal? It's at 1, but what does it ask for?
All the
Points, right? There's only one point, but have I found the point yet?
No.
What does a point consist of? X and a y. So 1, plug in the 1. 1 minus 2 is negative 1, plus 6 is 5. It is the minimum. So we successfully just found the minimum without a calculator, which is kind of a cool thing that we can do that. that will be chapter 3's
Is that all of it?
discussion. Yeah, there's only one.
And will there be like
If this were a quadratic, there would be 2. If it were a cubic, there would be 3. Well, maybe up to 3. Suppose f of 2 is 7, f prime of 2 is 4, f of 0 is negative 2, f prime of 0 is 2. Use a local linear approximation to estimate 2.1. Okay, that sounds scary. When you hear this word, local linear approximation, you read tangent line. So write that in your notes. When you read local linear approximation, you read tangent line. Why do you think it's called a local linear approximation?
Where it is not in straight line.
Right around the locally, a line approximation, which is a tangent line. So when you read local linear approximation, you do a tangent line. If I want to estimate 2.1, where should I do the tangent line at? 2. Notice they threw in some distractors. They put f prime of 0 and f of 0. I don't want the tangent line at 0. That's too far away from 2.1. So I do want to do the tangent line at 2, which means my x is 2. What is my y?
Plug it in.
Okay.
We don't have any equation.
I want to know the y value at 2. 7. How do you know? It says 7. What's m?
Rise up.
4. How do you know? It said so. They gave me everything I needed. It looked scary, but it's actually easier, isn't it, than the problem we worked earlier?
Wait, where's the slope at?
F prime of 2.
Oh, okay.
Okay. And then what do I do to approximate f of 2.1?
Get y secreted.
Not a word you could use.
Yes, it is. Sort of. It has the same. Okay, whatever.
It has about those letters in it.
Do you hear them?
Y'all
They're-
be nice.
They're being mean.
They are.
And it's not recording. I'm going to try to stop the gas.
we can turn off.
I'm gonna get stuck like Chris.
Again, why did I do an approximation here? Because it looks like I've done exact work. Tangent line is an approximation to start with. AP is a little bit picky about that. Sometimes they'll count off on open response if you put in equals there. If you put f of 2.1 equals 7.4.
Or you can cut off on our tests.
No, she wouldn't do that.
I would too. If AP does it, I would. I gotta prepare you.
It's not till next year.
Yeah, you need to do this right. Yes, you need to do this
I
right.
thought you were my friend.
No, I'm your teacher.
Oh. So we can't be friends.
Oh, we can if you're okay with me being your teacher first. But I have to teach you.
So you're going to take a friend request if he doesn't accept you as a teacher.
Yeah.
Oh.
We got this.
I mean, I could be easy and you could all fail the AP exam. Or,
You're not even gonna be here next year.
but I still care about your AP scores. Because you care about your AP scores.
Stuff you tell us now that we don't practice next year.
But you will. You will. It's, you will do a great job. That's right.
Yeah, super. Next time.
You'll pass.
That's a good
Do what?
That's a good motivation.
What? That you'll pass?
No, if he wants to pass, that's his goal.
Graduate high school, you get
Do what I tell you to and what Mr. Billingsley tells you to, and you'll pass. Alright. Quit talking. Find an equation of a line that is tangent to the graph of f and parallel to the given line. Find an equation of a line that is tangent to f and parallel to this line. How am I going to do that?
Find the same slope.
Okay, I need to know the slope of this line. Does everyone agree with that? Okay, so get y by itself. 3x minus 4 equals y. Do we agree?
Yeah.
So this slope is 3. So I want to know, when does this have a slope of 3, right?
Derivative.
Well, let's find the derivative.
3x.
And I want to know, when does that equal 3? And?
Divided by 3. Get y. X squared. Do 1.
And?
Plus or minus.
Y and negative 1.
Square root.
Square root, you get a plus or minus when you take a square root.
I got it up to 1.
So those are the two x values. It says to write the equation of the line, right? What else do I need? I have x and m. I need y. So what are the y values at 1 and negative 1? Negative 1? So there are actually two tangent lines. Y plus 1 equals 3 times x plus 1. And y minus 1 equals 3 times x minus 1. Those are the two equations that are tangent lines to this that are parallel to that. Any questions about that one?
So why do you take that equivalent to be your,
The 3?
yeah?
What's parallel mean?
I mean, yeah, but like, why did you not pick the equation?
I want to know when these are parallel. They're parallel when x is 1 and negative 1. Now what is f prime at 1 and negative 1? Plug it in real quick. Look. What is f prime at 1? 3. So I set this equal to 3. I wanted to make it equal 3 because I want them parallel.
How would you do it?
I guess
so
I should take the slope of that one.
This f prime of x, is m, right?
Oh, okay, so that's
Isn't it? It's the slope. And I want the slope to equal 3.
okay.
That makes sense.
Yeah.
We don't need to do that.
No.
Okay. I think this is the last slide on this lesson. Okay. All right. So match the graph of the function a through d with its derivative, 1 through 4. So the red ones are derivatives. The blue ones are originals. And I want to match those graphs. What would I look for? What's one thing that I could look for first?
Nope. How many times you cross the series?
What's a derivative again? Slope, right? So, first thing I would look at is these 2 points. Why? What do I know about those 2
It
points?
doesn't exist.
What is the slope at those 2
It
points?
doesn't exist.
0?
0, right? It is a horizontal tangent line, and the slope of a horizontal line is 0. So, which one crosses the x-axis over here somewhere and over here somewhere?
4.
4. I think those are a match. Because they have horizontal tangents, the derivative should be 0.
Okay.
Because this is the graph of the derivative, right? It should be 0 when this has horizontal tangents. So let's look at this one. Where does it have a horizontal tangent?
0.
At 0. But so does this one, right? So let me check this next one. Where does it have horizontal tangents? It has 3 of them, right?
So
Here, here, and here. So this looks like 2, which means that would be 3. And that's 1. Now, this one you could only work off horizontal tangents and get there. But let me show you something else to look at. This function, what's the slope over here? Positive or negative?
Negative.
Negative. Then,
positive,
then,
negative.
negative, positive, then negative. Below the axis, above the axis,
Also,
below the axis.
It's like it's just like a 1 on something, and then flat. It's like an X, like on B.
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 B. It went in here, this weird spot. Is that what you're talking about?
No, I meant like after 0.
Oh, yes. This has a constant slope.
Yeah.
All right, your homework tomorrow. Both are due. Tangent line homework. Is this written at the top of the tangent line page? Okay, so it's not a new assignment. No new assignment tonight. Both are due tomorrow, though. Implicit, you should be finishing up the 2 problems that were second derivatives. Tangent lines, starting on those. Did I hand you your AP packet yet? It would not be a bad idea to start looking at those problems. They're tough. Some of them are tough.